Section 1.3, example 4 on page 24, we have an equation that is true for every possible value of the variable is an identity. For example, x plus 1 equals x plus 1 is an identity. Both sides are identical. An equation has no solution if there is no value of the variable that makes the equation true. The equation x plus 1 equals x plus 2 has no solution. Notice there's an x on both sides, so those match, but the plus 1 and the plus 2 don't match, so there's nothing we could plug in that would possibly be that thing plus 1 and that thing plus 2 at the same time. Example 4 says, what is the solution of each equation? So we've got two parts. We're going to do part A first, try to isolate the x, and then part B, we're going to try to isolate that m. In part A, 10x plus 12, we have no like terms on the left, but then on the right, we have 2 times 5x plus 6. This needs to be distributed before we can check if we have any like terms. When you distribute the 2 to the 5x, you get 10x. 2 times positive 6 is positive 12. Now, technically you can stop right here if you catch what happened. If you didn't, try to get all your x's on the same side. So notice I've got a 10x over here and I've got a 10x over here. I want to move them all to the same side so I can undo my plus 10x by subtracting 10x on both sides. When I subtract 10x from 10x, that's a 0 pair. Bring down my 12, bring down the equal sign. Again, 10x minus 10x is a 0 pair, so I can bring down my 12. Now it should be super obvious. 12 equals 12 is a true statement, so we would say that this is an identity. Now, I did say you could stop up here after your first step. If you notice that 10x plus 12 equal to 10x plus 12 was identical on both sides, you didn't have to do the minus 10x step. You could actually have stopped right after you distributed if you caught that they were the same on both sides. So our final answer would be, because 10x plus 12 equals 10x plus 12 is always true, there are infinitely many solutions of the equation. The original equation is an identity. Now for part B, we have 9m minus 4. There are no like terms on this side. On the right side, we have negative 3m plus 5 plus 12m. We have 12m and negative 3m that can be combined. So the left-hand side stayed the same, 9m minus 4. And then 12m minus 3m gives us 9m, and then we bring down our plus 5. Again, you could technically stop right here if you catch it, but if you don't, try to get your m's on the same side. So we have 9m and 9m. To undo the 9m on the right, we can subtract 9m on both sides. If I subtract 9m from 9m, that becomes 0 pair, so we bring down our negative 4, bring down your equals. Again, 9m minus 9m is a 0 pair, bring down your 5. We end up with negative 4 equals 5. Now negative 4 does not equal 5, so you can always cross that out to have a not equal to symbol. And because negative 4 doesn't equal 5, there is nothing you can plug in that will make this true, so this equation actually has no solution. So part A was an example of infinitely many solutions because we had an identity, and part B is an example of something that has no solution that will make it true. The next two slides have all that work written out, and then on page 25 we have a little summary. When you solve an equation, you use reasoning to select properties of equality that produce simpler equivalent equations until you find a solution. The steps below provide a general guideline for solving equations. So step 1, use the distributive property to remove any grouping symbols. Use properties of equality to clear decimals and fractions. Step 2, combine like terms on each side of the equation. Step 3, use properties of equality to get the variable terms on one side of the equation and the constants on the other. Step 4, use properties of equality to solve for the variable. And step 5, check your solution in the original equation. This is a great little box with a summary to have somewhere easily accessible when you're taking a quiz or a test. Checking did I do each of these steps is a great idea, so I recommend you write this on your notes or have this slide somewhere available. Now I would like you to try homework number 7, page 24 to 25. Determine whether each equation is an identity or whether it has no solution. So we have negative 6a plus 3 equals negative 3 times the quantity 2a minus 3.